HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 130, recorded live Friday, September 19th, 2008. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. And by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks JavaScript with Brendan Eich.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting down today with Brendan Eich, Chief Technology Officer at Mozilla Corporation. Thank you, sir, for taking the time to chat with me today.
You're welcome.
Now, there's a lot of really amazing stuff going on in JavaScript right now. It feels like there was an amazing resurgence, after XML HTTP request kind of showed up in Firefox, and Ajax kind of leapt out of the IE world and into the mainstream. But do you think that JavaScript as a language has moved much beyond kind of its 1.2 kind of state? Has a lot happened between then and now?
I think so. A lot of dot releases, at least on our side, we've been adding values to JavaScript over the years. So 1.5 was the release from 10 years ago, and we've done a 1.6 that was in Firefox 1.5, if I recall correctly. We did 1.7, JavaScript 1.7 in Firefox 2, JavaScript 1.8 in Firefox 3. If you're seeing a trend here toward JavaScript 2, you wouldn't be too far wrong. We try to standardize what we're doing, and that was part of our work with the ECMA committee, and that's ongoing. It's a little scaled back from the ambition to unify the language in Flash Player, or the target Flash Player ActionScript 3 from Adobe, but there are certainly a lot of things in there that we'd like to get standardized. And as you said, the performance is really getting good now, so developers can start using JavaScript in ways that weren't possible before.
Maybe you could explain to kind of some of the laymen in the audience, or what is the relationship between ECMAScript 1.4, JavaScript, and an ActionScript? What is that relationship?
So some of these are trade names like ActionScript and I guess JavaScript too. That's a sun mark that I think Mozilla has been allowed to use for a long time now. Netscape used it originally through a trademark license. The ECMAScript name is sort of an anti-trademark. It's not really an attractive name. The ECMA standards body used to stand for European Computer Manufacturers Association. It's worldwide, and it's a fast track into ISO, the International Standards Organization, and its name is now just ECMA, a proper noun. So ECMAScript is one of the names used. The standard number is ECMA 262, and these are not names that are going to sweep the world and be on everyone's tongue. What the standard allowed us to do back in the day with Netscape and Microsoft was to agree on how the language should work at its core, which is the fundamental syntax and semantics, not including the document object model or the browser sort of APIs that were there in those days. And that standard, in spite of too many flaws, is actually a pretty good standard, all things considered, because a lot of language standards don't have to be accurate in the crucible of the web, where interoperation is king, where web developers know if something works differently in Mozilla versus IE, they can tell, and you can't hide anything. A lot of computer programming languages are underspecified intentionally so that compiler writers can make them go very fast, and they are used in various forms behind firewalls or in silos. So you use Microsoft Visual C++, or you use the GNU C compiler, or a number of commercial compilers, I think, which used to be more popular and have been eclipsed by one of the two, GCC or Microsoft's C compiler. Those compilers didn't all agree on how the C language or the C++ language worked, not just because the standard was underspecified on purpose, but because there were actual bugs or quirks in those compilers, and no one noticed because the code didn't have to work across the web. So JavaScript is probably the most interoperably implemented programming language in the world. So the ECMA standard was the basis for that interoperation, but the browser vendors try to agree at least on that much. Sometimes there are things that Internet Explorer never fixed based on the ECMA standard, and we've had to actually change the standard to match reality, because a market leader, as IE was and remains in some ways, can set the de facto standard, and it trumps the de jure standard.
Do you think that what do you think about some of the liberties that are taken, like whether it be IE or some of the liberties that Adobe takes with ActionScript, and the tend towards static typing? Do you think that those things are a little bit of a tug of war, or do you feel that you firmly, you and ECMA firmly have a grip on where JavaScript is heading?
Well, Adobe did something for their developers that was designed to make sort of Flash development more like, Windows or Java swing development, dealing with a toolkit with a class hierarchy, having the ability to write down type terms to annotate the types of variables and arguments. This has benefits for programming in the large, for making APIs where you can count on the values coming in being well conditioned or well typed. There are limits to it. We're all familiar with from other languages, because many languages in the current state of the art have somewhat weak type systems. Languages with very exotic, strong type systems aren't used that much. I'm thinking of functional languages like Haskell here. Though I would say Jane Street does a lot of OCaml programming, so there's an exception. But really, ActionScript 3 was in some ways trying to appeal to Java programmers, or maybe you would say C++ or C# programmers. And I think it's been successful in its domain. The type system in ActionScript 3 was influential in our work on the 4th edition proposals for ECMAScript. And there's still an active conversation in the ECMA committee to add an optional type system, which is what's in ActionScript 3, to JavaScript. Now, it wouldn't be something where you had to annotate all the variables. You could write good old untyped JavaScript like you do today. And indeed, you can do that in ActionScript 3. You're just, I think, encouraged not to by the tooling that Adobe has. But there are reasons for that tooling to want things to be fully typed. If you're just doing JavaScript for the web, it's untyped today. If we ever do standardize a type system, I think it'll look like some of the things we worked on, and maybe it'll have some other features, but it will be optional, and it'll have a sort of dynamic flavor. There won't be this ahead-of-time checking that says, well, your file loaded, but we can't compile it because of some type error, and so you're not going to have any rich AJAX web app experience. Sorry. It'll be a dynamic language, like Perl, Python, and Ruby, with optional types. And those languages have had experimental variants. In the case of Perl 6, I would say, have type systems added to them.
So it sounds like from your answer that as a language wonk, as a person involved in languages, that on the axis of purist versus pragmatist, you're kind of flat in the middle. It doesn't sound like you're really pure dynamic languages. There's a pragmatism to what you're saying that is a little surprising.
Yeah, I'm not religious. I have been a Unix kernel hacker, which was writing in C, which is portable assembly language. I've played with a lot of languages and implemented language processors for my whole career, and going back into graduate and undergraduate studies. And there's a sort of a dual, or a sort of a correspondence between statically typed languages and dynamically typed languages. You can make proofs out of your programs in statically typed languages, if the type system is sound, by writing down types of variables and arguments and return values. And these proofs can be helpful, or they can just be kind of tedious and still not keep your program from crashing, depending on the nature of the language and the nature of the type system. So, and if you have a really sort of advanced type system, like in Haskell, you can do some amazing things, but it's not yet well taught, and programmers tend to bounce off it. So maybe that will be the way of the future. I'm actually a fan of languages like Haskell, but right now people are being taught Java. It's sort of like the new COBOL. It's safer than C++. It's memory safe. There are no ways to forge pointers or bad memory addresses. But its type system doesn't do a lot for you, and yet it requires you to write things down, sometimes redundantly or sometimes tediously and sort of without real benefit. So the dynamic languages community has had a resurgence lately. You've seen this with the books on Ruby versus Java and sort of these fake food fights that happen, like Ruby on Rails versus the three-tier Java architecture. That with dynamic languages, you can sometimes write very generic functional code, functional programming that doesn't have to worry about types because it's universally quantified. It works on any type. And you can be very productive. And with the right debugger and testing, you can go a long way. There still can be benefits to having some kind of type or contract system. That's another sort of dynamic type system that's actually very expressive, where you can have your APIs decorated with extra declarations that say, here's what the type should be, or here's what the contract should be. And when someone violates that contract, I'm thinking particularly of the contract systems in Scheme, you get a good arrow of blame pointing to the originator of the bad value. And this is really good for debugging. Right now, bad values in JavaScript tend to lead to foo has no properties, or undefined is not defined in IE sort of error message. And that's no fun at all.
But that's a contract system, no, not a type system, right? That's an interesting distinction.
There is a distinction. It's not a static system that you can prove facts about. So it's an open question in my mind, at least, how much benefit there is to adding an optional type system as opposed to a contract system. People would like to write down certain facts about APIs, but do they really need to say this loop variable is an integer? I don't think so. And I think that the optimization work you're seeing in JavaScript engines right now makes that a moot point as far as performance. Because in the past it's been said, to make your code fast, you must, add a :int type annotation to your var I that's used as a loop control variable. And I just don't see that that's either fruitful or necessary for performance. The really interesting type terms that you'd like to write down are more like contracts. They are more like higher order types and ways of saying things at the API boundaries. But inside the implementation of the API, or inside the client that uses the API, you may be able to have untyped code that goes super fast and doesn't need heavy type annotations.
Mm-hmm. Now, how do you think that contract would relate to something like OpenAjax metadata? I mean, it sounds like we're all kind of dancing around. We want to keep JavaScript fast and loose, but at the same time, we want our IntelliSense, we want our tooling, we want better IDEs. There was a long time there where everyone was writing JavaScript and VI and Notepad, and suddenly there was this, this resurgence of IDEs and better tooling and debuggers. Now we've got people trying to get in more metadata. People want IntelliSense for jQuery. They're adding metadata in comments. Wouldn't a contract system give them the same stuff that this OpenAjax metadata would provide?
It might, or a decorator syntax like you see in other languages, like in Python and Java as well, C#. Sometimes you try to wedge things into this sort of domain-specific decorator language that really should be properly thought through in the main language. But here's an example. It's not a contract system. It's a real type system. This is something we've explored in the ECMAScript 4th edition proposals. A structural type system would be a way of describing data, sort of like JSON data, objects and arrays of strings and booleans and numbers, and you could write these in nested fashion, and these types, these structural types, would not have names that defined their equality or their identity. It's not like writing a class declaration in Java. You're actually saying it's a record. It has these three fields, and the first one is red and its type is number, and the second one is green and its type is number, and the third one's blue and its type is number. This kind of structural type system has been used in some languages. We think this is possibly more valuable than a nominal type system that is a class or interface type system. They both have use cases. They're somewhat complementary, but if you look at how people do JavaScript today, they program around JSON, where there's sort of a latent schema in the code. There's an implicit schema in their heads. Programmers writing dynamic languages do write well-typed code, and I can get into that when we talk about optimizations, because at least for Mozilla's approach with TraceMonkey, we depend on there being stable latent types in the code, and indeed there are.
Well, we should talk about that, because I think that JavaScript is getting incredibly fast, but there's things that have been around like Rhino, of course, an open source implementation of JavaScript written in Java. Microsoft's got managed JavaScript running in the CLR, DLR, the dynamic language runtime. So people are building these dynamic language jitters on top of existing static language jitters. But TraceMonkey and V8 are heading in a little bit different way, aren't they?
Yeah, you'll hear this claim made about like the Java VM and the CLR, the .NET runtime, that they were designed for static languages, and that shows. So when you have a dynamic language mapped onto them, it doesn't always perform as well, or it has to do more work to optimize itself. It doesn't get things for free from the runtime, and sometimes the runtime actually gets in the way. Whereas with something from scratch like Google's V8 or TraceMonkey, which is an evolution of SpiderMonkey, the interpreter we've had in Firefox for a long time, we can do things just for JavaScript and just for the dynamic language performance that we need.
Hi, this is Scott Hanselman with a word from our sponsor. Do you know how to build Web 2.0 AJAX applications with Web 1.0 components? You really can't. If you want to do the next generation web applications, you'll need next generation components, just like the ones that our friends at Telerik have got. They're RAD controls for ASP.NET AJAX. It's a huge pack of web controls built on top of ASP.NET AJAX that'll add previously impossible performance and interactivity to your next project. The new controls mirror the AJAX API from ASP.NET, so development is really straightforward. The client scripts are shared, so loading time is not a problem. If you just set a couple of properties, and you'll be able to automatically bind to web services for a really efficient operation. The new RAD editor from ASP.NET AJAX Telerik loads up to 4 times faster than before, and the new RAD grid handles thousands of records in just milliseconds. But as always, it's best to try for yourself, so you can visit telerik.com/ASP.NET AJAX and download a trial. Thanks a lot. There's some interesting speed stuff going on up on your blog at Brendan's Roadmap Updates. You've got some charts, and there's a little bit of an arm wrestling match between TraceMonkey and V8. V8 seems to be a little bit obsessed with recursion and likes to show that they're a gajillion times faster in this particular micro benchmark. In your graph, you're showing that the TraceMonkey is pretty darn favorable. But one of the points that you make is that you developed it a lot faster. They've been working on V8 for quite a while.
I don't know if that's true. I met Lars Bach once. He's the VM guru who created V8, and I think he works very quickly. I wouldn't be surprised if he had gotten the bulk of the work done very quickly. So no disrespect intended, but they only released it after a couple of years at Google. And that may have, and frankly, that may have hurt them, because when you do open source development, it's best to release early and often. And in fact, in the Google Chrome comic, they talk about releasing early and often, but they didn't actually do it in this case. The two approaches are different, though, TraceMonkey and V8. And right now, we're working on getting our performance and recursion to be better. Google has focused on some benchmarks, some of which are kind of macro. They're very object-oriented JavaScript, very stylized, in a way that you see on the web, though in some ways it's even more layered than the web apps JavaScript code that I've looked at. And they are heavy on recursion or heavy on sort of method dispatch. And with TraceMonkey, we can inline methods very quickly if we can handle all the case combinations in the SpiderMonkey bytecode. We're simply working through uncovered cases to stay on trace, to not abort the recording. And as we do that, you'll see us get faster and faster. And we'll see how it goes. I don't want to, brag at all, and I wouldn't want to claim results before I had them. But as I said in the blog, I do believe that the tracing approach gives us a unique way of looking at what the program's actually doing, its current set of values, the latent types that are there that may not be evident from a static analysis of the code. And that should let us go very fast. It should let us specialize as well as inline. And the combination of inlining and specializing can keep our code footprint small. It can make us generate very tight machine code that doesn't have to worry about case analysis at runtime. V8 is probably going to get into speculation more and more, but originally when I looked at it, and I don't know if it's changed much, they were doing sort of, is it this case of the plus operator, which concatenates 2 strings, or is it that case of the plus operator, which adds 2 numbers? And maybe to optimize further, is it the case of the plus operator where the numbers both can fit into machine integers and not overflow into double precision floating point? That kind of code generation makes for more code. And because you're doing those tests, it runs a little bit slower. With tracing, we can speculate that, it's only integers, it doesn't overflow. We're going to put a very quick guard in, so there's still a little test overhead, but it's smaller. And we're going to just use integers all the way. And that allows us to do really well on these micro benchmarks. You saw us beating V8 on micro benchmarks, I think, more than macro. And we're just going to have to keep competing and see how it levels out.
So just to make sure that the listeners are following this notion of tracing, I mean, are you watching it run slowly once by basically instrumenting it in real time and then doing your nano jitting? Does it in fact run slowly for a moment, or do you? I mean, there seems like it's a little bit of a Schrodinger's cat thing. Did the JavaScript run or not? I'm not quite clear on how you are in fact seeing this happen versus doing a static analysis.
Sure. This is based on work Andreas Gall did for his PhD thesis under Michael Franz at UC Irvine, and it's novel work. It has very few predecessors in computer science research, and Andreas's twist to it made the traces be prettier in structure and have sort of a tree structure that allows for larger scale optimizations. But we are recording what the interpreter does. So we have an interpreter, which means a byte-coded interpreter. People probably know what that is, where you generate a pretend instruction set. It's like a little toy language, machine language, and you interpret.
So SpiderMonkey is still there.
SpiderMonkey's still there. It's still got an interpreter. V8 does not have an interpreter. They parse JavaScript into syntax trees, and then when they see something has to run, they can do this lazily, so they don't have to do it up ahead of time. They then go generate machine code directly. But as I noted, it still, in general, has to be machine code that says, is it case number 1? Is it case number 2? Is it case number 3? In order to handle all of the dynamic case combinations. Whereas with tracing, we let the interpreter handle loops, and when loops look hot enough, when a simple way of counting loop frequency trips, we can then say, okay, we're going to start a recorder, and that's just like a VCR for your interpreter. It adds a little overhead for that one iteration that it tries to record, but if the iteration completes, if the loop body control flow reaches back to the top of the loop again, then recording is done, and we get this beautiful linear stream of instructions that we can use modern optimization techniques on. And because it's linear, it's branch-free. All these modern optimization techniques become very simple and efficient. Whereas if you were using whole method compilation or compilation.
Right. By avoiding a holistic view, by actually focusing in on giving yourself tunnel vision, then you make things look more linear than by basically a small bite at a time.
Yeah, and like I said in my blog, you free the interpreter from being neurotic about, well, the same thing didn't happen next time, but I'm going to keep testing just in case something might change. They say the definition of neurosis is doing the same thing over and over, expecting a different result. The interpreter is doing this sort of case analysis that the generated V8 code is doing. It's saying, is it a string? Is it an integer? I don't know. It could change. But when you record a trace, you stipulate, well, it's an integer. Types are stable in dynamic language programming. We're going to put a very efficient guard instruction that will bail out if it's not an integer, and then we're going to proceed assuming that it's an integer. And because you have this linear loop body fragment, this trace, you can consolidate the guards, you can eliminate guards you don't need, you can consolidate various kinds of loads and stores, and you can make the code very tight.
How much faster can this get? I mean, how much headroom is there? Is there another factor of 10 improvement that's hiding somewhere? Or, I mean, when are we going to say we're done?
Well, so with these micro benchmarks, we're getting close to sort of the speed of a unoptimized C compiler. I think Mike Shaver showed in his blog running GCC with -0 or some, turn off the optimizer, and we were getting close to that. So we don't need to go 10x faster. We're going to hit the speed limits that are inherent in the machine code. Hand-tuned machine code can beat a C compiler still, but it's really not worth it. If you're going to see 2x improvements or 3x, linear small factors. We haven't even got a decent register allocator in TraceMonkey yet. We haven't done some redundant guard and load and store elimination optimizations that are easy to do. They're just work that we haven't had time to get to yet. And when we get to them, you'll see doubling or tripling, I think. And that will help because apart from the benchmarks where we're falling off the trace, and you see our speed in the sort of long tail presentation on my blog, get back to where the interpreter is. We've degraded the interpreter, essentially. We don't get any jitting speed up. As we get those cases covered, we'll start to get speed ups in those benchmarks too. And then I think across the board, you'll see this sort of 10 to 20, 30x speed up from what was in Firefox 3, which was just the interpreter.
Now, doesn't it seem like we're talking about theoretical stuff? We're talking about JavaScript as a language doing things like ray tracing, but who's really going to ray trace with JavaScript? Doesn't it? With any language, things get slow when you hit the disk, and in this instance, JavaScript hitting quote unquote the disk is talking to the DOM. Are we then going to move our focus towards DOM manipulation as being faster? Because when JavaScript is as fast as C, things are going to get slow when we start generating our divs dynamically and all that kind of stuff, when we start doing our jQuery work.
That's true. And so we're working on tracing into the DOM because the same sort of beautiful specialization you can do with this trace tree approach that Andreas Gall pioneered applies to the DOM code. In fact, the DOM code in most browsers is a bunch of C++, and it's object-oriented C++, so it has what are called virtual methods. So it has some amount of polymorphism, some amount of ability to make similar types look like a single type, and that has a cost to it. But the bad thing about it is that apart from any sort of profile-guided optimization you throw at the compiler, it really doesn't know what's going on in the trace. But if you could trace into the DOM, then you could make the same sort of type speculations that we're doing in the pure JavaScript world, and you can make your DOM code go really fast. That's point number one. Number two is that there are elements like the canvas tag that's in Firefox, and Safari, it's in Opera, and there are ways to sort of shim it into IE, and I hope Microsoft implements it because they could easily do it. The canvas tag gives you a low-level sort of rectangular programmable image, and you can get different kinds of APIs to draw to it. There's a standard 2D affine transform API. There's other proposed APIs. We have one that's OpenGL-ES for 3D and texture shading and using the GPU even. When you get really fast JavaScript and the canvas tag, maybe you don't need the DOM. Maybe you make your own DOM in JavaScript because, hey, the DOM's just an old standard from the 90s. Do we really think that's the last word on object models? Certainly not for games. Games have their own scene graphs and their own ways of doing, a level of detail. So I think super fast JavaScript plus Canvas is going to be huge. You're going to see not only games, but sort of visualization tools and all sorts of things.
Well, doesn't that mean if you add Canvas, you have super fast JavaScript, and you have video, you have HTML5 and the video tag, what do you need Flex and Silverlight for?
It's a good question. And Adobe's been a good partner, certainly contributing Xamarin. We use the Xamarin tracing NanoJIT as a big boost to TraceMonkey development. It's a little backend for recording traces at a low level and generating machine code. It's a sort of low-level intermediate form code generating backend. But we have to make browsers better. It's just in our DNA. The web has to evolve, and it is evolving. And at some point, I think this becomes disruptive to things like Flash and Silverlight. Now, Flash still has lots of value to offer, and Silverlight is in many ways a Flash clone. So those will be around. They have tools, fine tools that I don't think anybody's really seen on the open web side of it, though Aptana and the Open Ajax guys, there's efforts there. Our own efforts and tools have been more about doing it by hand, but also Firebug, this sort of integrated debugger that gives you complete visibility on the sort of computed styles and the cascade of CSS styles, and gives you little ways to tweak things and see all the network latencies in your HTTP requests. We're going to work on Firebug. We're investing more in it, and we're going to make it even better. And I think JavaScript debugging is going to become really good. Like you'll get time-traveling debuggers that let you go back and see where that bad value came from, things like that. So I think there'll be a lot of coexistence among Flash, Silverlight, and the open web, and this is what I'm working on, so maybe I'm biased, I think the open web will become just as competent, maybe not quite as coherent. When you have these single-vendor proprietary stacks, you can make something that's laser-light coherent as far as developer docs and polished APIs and a tool experience that's really nice. You asked about things like type-down autocomplete. Firebug just has a bunch of tables of well-known DOM property names and JavaScript keywords, and you can go a long way with that. So depending on the nature of the dynamic language and whether you really need those type annotations to go fast, maybe we can do a sort of a 90% case, worse is better case that has good tools. And I think that's something to work on. The open web's tooling is not where it should be. Were it to get where it should be, I don't think it would look exactly like Eclipse. I think it would be lighter weight. I think it might be more integrated and more like Firebug.
Yeah, so it sounds like 5 years down the road, JavaScript is C speed, it's competitive with Flash and Silverlight, and maybe not even as coherent on the page, because certainly with Flash and Silverlight you kind of draw a square and you say that this is where Flash is and this is where Silverlight is, and then there's bridges that go back and forth, but I assume you think that there's a benefit to having no bridge, to not having to jump inside or out of the object tag.
I think so. I mean, the plugin vendors, and I say this as someone who appreciates Flash for what it does, when you encounter a Flash plugin, you may not have the events work right or the tab key might not take focus into the plugin or take it out again. These are bugs that we're working on with Adobe, we're trying to fix, but there will always be such bugs because you have the separate code base of a plugin, and you have this sort of narrow plugin API that we've been working to evolve, but which goes back, to Netscape, to the Netscape 1.1 release, I think. So, or on Microsoft side, you have ActiveX. There's just sort of the plugin is the other in some politically incorrect sense, and it gets put in the penalty box in various ways. Or if you build all your code on the plugin side, then the browser seems like it's in the penalty box, and it seems less polished and less flashy. So. Right. This kind of seamful experience is anathema to designers and a lot of users. So I think it should go away, and the market forces will tend to make it go away over time.
How are we going to get out of a backward compatibility? I mean, isn't Navigator.plugins and it's all of its history and all of its quirks and its lack of clean versioning and people splitting open the descriptions to look for tunneled versions and all those kinds of things? Are they going to be with us forever? I mean, there's backward compatibility in JavaScript that seems like it's hamstrung as it'll be there forever, don't you think?
It could be. The web is shortest path evolution plus compatibility till it hurts. But, it's changed a lot. You look at pages from 10 or 12 years ago that used the tables of that era, and maybe they use spacer images. They don't work right now, and it's a good thing. So you find that the intersection semantics between the browsers moves, and what web developers target moves. And, we're done with IE5.5, I think. Different locales may have different opinions on that one, but IE6 is still kind of an albatross. Hope it goes away soon. Things like Google Gears would hope to uplift new web features into it. The mobile web will cause, I think, a big shift toward more modern implementations of web standards, because I think the iPhone did open people's eyes that even though there's a fair amount of iPhone-only content that is not quite open web, and some of it's tied into the exact screen dimensions of the iPhone or even to Apple's platform. But be that as it may, they did move people away from sort of the WAP, WML, mobile web, this thing that was still kind of a threat to the open web a couple of years ago. So mobile is going to, I think, help modernize standard support and obsolete old web content that just isn't worth keeping compatibility with. But you can't really predict this. This is something that I keep saying in the context of JavaScript. You have to be careful not to try to say, we broke compatibility and you should know better. You should go use our new feature Y instead of that bad old feature X. That doesn't work, because often you're not even talking to a developer. The developer who did it was a contractor on a gig 5 years ago, and they're long gone. All you've done is make the user suffer. Your mom at home, the page doesn't work right. What good did you do? So compatibility has to be kept until it hurts, but you have to keep using the carrot of innovative new features and keep competitive browsers being numerous, being used in contexts like the mobile web and in desktop settings like Firefox is. Compete, and good things will happen.
Okay, that's fantastic. I got one last question. I know you've got to go, but what do you think of jQuery? And do you think that jQuery and some of the kind of explosion of frameworks really kind of raised the water level and kind of reminded people that JavaScript was still out there? Was it the popularity and the flexibility of those frameworks that reminded people that you could really do some powerful stuff with JavaScript?
Oh, I love jQuery, and I should give a disclaimer. John Resig works for Mozilla, and he's just very bright and great. It's wonderful to see him do demos. He'll do them without a net in his editor, and then he'll reload and show the effects that jQuery has. And he did amazing stuff with processing, this visualization language from MIT.
Yeah, we had John Resig on the show last week. Did he work for Mozilla when he wrote jQuery?
No, we got him, I think, after he launched jQuery. I remember I met him at the Ajax experience in 2006 in Boston in the fall, and I thought, wow, another Ajax library, isn't it too late? But of course it wasn't, and jQuery has really just zoomed to prominence since then. You have to give credit to Dojo and Prototype and others that came before. I have a soft spot for MochiKit. All these are good. We're still in the early days, so people are not just building better Ajax libraries like jQuery, they're also building plugins for them, or higher level turtles on the backs of turtles, to do things like make it really easy to not just build your user interface or a widget, but your whole app. And we're seeing that now, that kind of evolution with JavaScript frameworks coming online, and it's pretty exciting time still.
So it doesn't seem to me like you think that we're anywhere near the top of the popularity curve of JavaScript.
No, I think that just now with these high-performance engines, people are starting to think, but when they actually get them in their hands and can use them, it's just going to be amazing.
Fantastic. Well, thank you so much, Brendan Eich, for sitting down with me today. I really appreciate your time.
Oh, my pleasure.
This has been another episode of Hansel Minutes, and we'll see you again next week.